Welcome to my channel AI Basics with AK. Here we are with another new episode on lambda functions with map, reduce and filter, which we have discussed in the previous episode. Why waste time? Let's jump directly into our episode. Episode 13, functions, both lambda functions and regular functions with map, reduce and filter. I have kept my reference that has been used while creating this episode in this link. You can also browse through this link, which I loved it a lot. Topics for this episode, as mentioned, we will go through map, filter and reduce one after the other. So in our previous episode, we have seen how we can define an area of a circle both using regular functions and lambda function. Here we'll just review of the lambda function that we have seen in our previous video. So for defining, we know that area of circle is pi r square, where we can use an anonymous function lambda using variable, that is radius, colon, a separator, and then our executable function or return statement, whatever it is, which is pi r square. And then once we call this area of a circle as 3, we will get this function. Say for example, we want to find area of a circle for these 4 circles with this respective radius. Like this circle has a radius 1, this circle has a radius 3, this circle has a radius 4, this circle has a radius 5. Using list comprehensions, we can do it very simple. Like for I in find area, where we iterate each one of these circles, and then for each one of the circle radius, we will call this area of a circle function iteratively. And then we are storing this entire output automatically in our list comprehensions by using a square brackets. Then we can see the output below with respective radiuses, its circle area. Pi r square, which is radius is 1, so that's why it is 3.14, which is pi itself. And respectively, as radius increases, you will get an 3 square, 4 square and 5 squares gets multiplied with respect to pi. So instead of using a list comprehensions, we can directly use a map function here. Map, while using map, it's very simple. You can use a map function with a function and its respect to iterator, which iterates over each and every iteration. Like how we are using a list comprehension, map does the same thing, but it's more powerful. But I'm just explaining you the functionality, how it executes it. And by looping this iterator automatically, it runs this function at each iterator. So we can just call this function map directly instead of using a list comprehension. So we will see the same output. Also, you can create your own custom function instead of using a lambda function that we see it here, and then call the same map function, and then we can see the same output here. So the outputs of list comprehension in this map remain simple. The map is much more powerful because we are not iterating using for loop. For loop, when the loop is very lengthy, it becomes slower. However, map avoids that looping because it has an inbuilt iterator which iterates along this list and then just calls the function easily, and then it gives an output directly in a list format, because we are using a list as an output here, because we are saying give the output is in a list. So that's more about map. Now let's jump into filter. Filter, say for example, we have seen this example in our previous episode where we want to identify is given number is even or not. This example we have already seen it in our previous episode. Say for example, we want to filter even numbers from this list. How do we do that? Using a for loop, where we are calling a for loop, and then we are saying if it is even, then give me that number, and then we can store that entire piece in a square brackets, which gives our output in our list. So it says that number 4, number 6 and number 8 out of this list are even numbers. Instead of actually writing this complicated or a lengthy list comprehension, we can just write filter with our function name and then our iterator list. That's it. Automatically it filters whatever it is using this filtering function, because this is what it filters using this iterator and gives our output. Someone can say, why can't we use map? Map, it maps the function. If you can see it out in our previous list comprehension, here you can see that for I in find area, and whatever the output that comes out of this function output, the map uses that function output. However, in filter, we are using an if loop here. If is even, give me that output. So what filter does is that in whatever conditions this function is giving true, it gives that respective values directly. So that's why it called filter. It is filtering the true values or whatever as per our condition. It gives those values and filters and gives to us directly. So this becomes much more powerful when we want to filter few specific rows, columns, etc. based on some condition or automated condition, that if we want to automate it. Especially we will see these powerful usage, especially when we come to pandas and numpys. That is in next seasons. And this reduce is much more powerful, especially that we will realize when we go through in our next season, which is more about, I'm dealing with more about statistics. The season 3 will be on statistics. So when we come to statistics, this reduce function, we will see it much more common, while actually when we are discussing about sum, mean, median, etc., we will try to use reduce function, and also the regular mean, median and mode functions that are already available in Python. So coming to the reduce function, here you can see that, say for example, we have two numbers, and when we want to add two numbers, we write the function in lambda or else in regular function in this way. Say for example, if we want to add all these numbers and this maybe changes. Say for example, this list is 1 2 3 4 5 6. Now this list has 6 elements, maybe another list has 10 elements, maybe another list has 20 elements. Now how to add this varying list together? We cannot keep on writing this for loops for each and every list, right? There has to be some quick generic function, and there comes our helper, this reduce. This reduce we can use by importing from functional tools. We have not discussed about how to import and how to read another libraries, but for this episode, if we want to use reduce function, we have to just run this function before using reduce, which is from functools import reduce. So reduce does the same, the syntax of both map, filter and reduce remains the same. It is like map, reduce and filter remains the same. It says function and some iterator. it remains the same, but each and everything is very different. Here it maps the iterator to the length of it performs this function across all this iterator list. Filter, it performs this iterator function and returns wherever it is true. Coming to reduce, if you can see here, this MySum function only adds two numbers. However, we are passing to this two number sum function this entire list in reduce. What it does is that it adds the consecutive numbers as it goes. Say for example, here it is 1 2 3 4 5 6. What it does is that it adds 1 and 2. So what is an output here? It is 3. Next it adds 3 and 3. What is an output here? 6. What is 6 and 4? It is 10. Like that, it keeps on adding the numbers as we move forward to the iterator. So that's why it requires only two inputs. Like here we require only num1 and num2, so it requires only two inputs at each and every time. Here for the first time it takes 1 and 2, next time it takes this 3 and 3, and for the third time it takes this 6 and this 4, and for the fourth time or fifth time it takes like 10 and this 5, etc, 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 as we move forward. Got it? So we don't need to use only for adding the function. Similarly, we can use in the similar way for multiplication. While multiplying, it becomes very simple, right? 1 into 2 is 2, and then 2 into 3 is 6, etc, etc. It is nothing but a factorial. So instead of creating a complicated factorial function, we can just use the simple function even for writing a factorial. Say for example, if we want to use instead of reduce any other map or filter, it is not possible, right? Because it says something num2, okay, some position argument it is throwing it out because it is not expecting num2. Say for example, if we want to multiply three elements together, is it the right way to do it? It is not possible, because if we are multiplying 1 2 and 3, maybe if the first time it gets executed and it says 6, but the output is 6, but it says it requires a next positional argument which is not there as we move forward to the iterator. So that's why it says it's missing one positional argument, z. So with this we have completed our content. So these three functions, which is map, filter and reduce, are very powerful function. Especially we will see it in our seasons 4 and seasons 5 once we cover the statistics season, and you people will appreciate the beauty of these functions, and of course we will review these basics again in that seasons. Okay, let's jump into our demo sessions. There is no homework for this week. See you on my laptop. Bye bye. On for both episode 12 and episode 13 of lambda functions, as well lambda functions with filter, reduce and map. In our previous episode 11 demo, we have explored functions using a def as a key variable. Let me just quickly run through it. So how do we define is that using a def as a key variable, and then the function name, and then these number 1, number 2, number 3 as arguments, and this is the body of the logic, and then this is the return statement of what we want to return out of this function. It can be a single return variable or else multiple return variables by using a comma. So we will explore, okay, in the similar way using lambda functions, and then we will see some operations of both map, filter and reduce, and then further we will complicate it. So let's create an addition function, simple addition function, which takes one argument, say number 1, and then let's during addition, it adds to itself. That is, we will return number 1 plus number 1. So how do we see this output? Just by using a print statement and then using a function name with a variable say 3. So here we can see that the output is 6 because it is adding 3 to itself. So it is 3 plus 3, which is 6. How do we write the same function in Lambda? Just by using a Lambda key variable. Let's create another variable called add Lambda, and then how do we define it? Using a Lambda key variable, which is Lambda, and then what is my argument? Number 1. What is my return statement? Number 1 plus number 2. It's as simple as that. And then how do we explore the output? By using add Lambda, which is my new function, and then say let's give another number here, 4. So output has to be 8. So 4 plus 4. Why it's throwing an error? Oh, okay, there is no number 1 and number 2. It has to be number 1 plus number 1. So yes, so here you can see that it's 4 plus 4, the output is 8. So some might ask, okay, when you're defining a variable called add Lambda, why we need an anonymous function? Certainly we don't need an anonymous function if we want to create an add Lambda. Ideally, anonymous function is called when we don't need to create a variable. So we are just calculating this entire operations on the fly and then extracting an output. So how do we do it? Just using print statement, and let's copy this entire function within parentheses, and then say we will use an input number 5. So 5 plus 5 is 10. If we want to change it here 6, so 6 plus 6 automatically gets updated to 12. It's beautiful, right? So just without defining a function here, we are just calculating it on the fly using Lambda function. Maybe we can just print 6 plus 6 without creating this number 1 and number 2 logic, but this is just a demonstration how we can write an anonymous function without actually creating a function. So let's explore in so far, even in the slides as well as right now, I'm just exploring for a Lambda function which is returning only one variable. Earlier, we used to return two return variables as well while defining def functions. Like say for example, we have def where I want to return both square and cube. Let's call it as square underscore cube, which takes a number 1 as my argument and returns number 1 square, comma, number returns and number 2 cube. So let's see whether this function is right or not. So square underscore cube, and then let's explore with a number, say 3. So 3 square is 9 and 3 cube is 27, right? So let's print this output. So that's the output we have already got it, which is 9 and 27. So can we return two variables even in Lambda function? And I would say yes, it is. We have not seen it in slides, but we can see the same in demo. How do we write it? Say square and Lambda. I'm just writing it for easier sake so that people can understand it. Lambda number 1, which is my argument, and then my return statements. Here I will open a parenthesis. My first return statement is number 1, 2, and my second return statement number 1 and 3. And I'll just use the same one here. Instead of 3, let's call 4. 4 is 16, and then 4 cube is 64, which you can see it here. So using Lambda function, also you can return multiple variables using the logic that we can write it out here. If there is a simpler logic like this and you want to return these outputs in two variables, also you can use a lambda function without much complications. Now this all looks good. Now say for example, if I have a list, say my list, which is 1, 2, 3 and 4. I want to do both square and cube to this entire list. Ideally, we have to use a for loop. Since we have explored in our episode 13 that we can use map function, let's explore, let's just check it out, just apply that here. So let's print map. What is my syntax? First goes the function, which is my sq cube underscore lambda, comma my iterator, which is my iterator list, which is my list. If you can see here, print map. Okay, so that's why it is showing syntax error earlier. Now if we can see it out here, because here you can see it is a map object. Since it's a map object, it is my duty to convert this into a list. So how do I convert it? First, let me convert into a list and then print this list. Now I can see it here. 1 square is 1 and 1 cube is 1. 2 square is 4 and 2 cube is 8. 3 square is 9, 3 cube is 27. 4 square is 16 and 4 cube is 64. So simply by using map function without using a for loop, I have just used this lambda function returning two variables, that is both square and cube, using a map function. Also, instead of this, actually I can directly paste this lambda function directly, copy paste this lambda function. Instead of sq cube underscore lambda, I can just use this as well. So the output remains the same. Say for example, if we want to use a new list and then actually check it out whether it is returning new statement or not, instead of 1, 2, 3 and 4, say for example, let me call it as 2, 3, 4 and 5, and then let's pass the new my list here, and you can see that it gets updated. So in this, I have not even declared any function here. I have just used my lambda function, and then on top of that I have used a map which took this function as well as my iterator and calculated the entire function of both square and cube for each element in the iterator. Beautiful, right? So say for example, what happens if I use a filter here? Filter, as we have explored in our episode, it actually returns if it is true. Since here all elements are greater than 0, by logic, which we have explored in our episode 1 or episode 2, it is true. So if we use a filter here, we will get the original output here, because each and every element is a true. However, say for example, what I'll do is that instead of first what we want to filter here, let's explore it out. That I want to filter it out any number that is greater than 3. So how do I write it? Number 1. Sorry. Number 1 greater than 3. So my output directly filters it out 4 and 5. Instead of filters, say for example, if I use map, you will see that it actually calculates false, true, true. So since my 4 and 5 are true, that because the logic is matching with respect to num1 greater than 3, only those numbers gets filtered and it will get printed out here. Can we filter two variables like how we are writing it out here in map? Can we do the same thing in filter? No, it would not be, because we can use a filter like an and or, but we cannot use a comma by returning to, because uh, it goes in combination, right? Say for example, if one of them is false and true, and here is false and true, it is very difficult for a filter function to filter out either of these things. So that's the reason it prints out everything. If we use the same, say for example, if I'm using filter where, say for example, instead of number one, say for example, I'm using number one, say comma greater than number two. Now what happens here? It prints out everything here, because it's taking by default everything, because everything it assumes it out, everything is true. But the moment if it is only one, it actually iterates in a nice way, because it's filter outs by logic and it's already filters 3, 4, 5. So when we are using filter function, our return statement has to be only one, where actually it can filter it out the variables. We cannot have two return statements out of hurry. Say for example, if you want to filter it out two variables at a single go, we cannot do that with filter, because it gets confuses. There is nothing much new to be offered while exploring the reduce function. So I request you to just go through the slides, and maybe you can click the Google Colab link and then just practice out the reduce function over there. So that's it for this episode. See you in the next week or in the next episode. Thanks a lot. If you like this episode, please please do subscribe, and then just comment, share, and like. Thanks a lot. Bye bye.